Okay, is that clear? Yeah, looks fairly clear. Okay, if we look at these are called root functions. Okay? And why they're called root functions is because they have a square root. If they had a cube root or a fourth root, any type of root, they'd be called a root function. So we look at when we have a root function, the key to this slide is we know that whatever's inside of the root, okay, whatever's inside of the root has to be greater than or equal to 0. So in this case, why they're saying is x has to be greater than or equal to 0. Why that is because you cannot take the square root of a negative number. So what's inside here cannot be negative, which is x, so it has to be greater than or equal to 0. Okay? That's pretty straightforward. So we look at the next one though. This one's a little more complicated, right? 2r minus 9, that's what's inside the square root. 2r minus 9. And that's why 2r minus 9 has to be greater than or equal to 0, because 2r minus 9 is what's inside there. So it's not the r that has to be greater than 0, it's the 2r minus 9. Right? So we have a little calculation to do. 2r is greater, so we take this to the other side and make it positive just like we would. And then we divide this by 2, just like we normally would an equation. And r has to be greater than or equal to 9 over 2. And that's why they get that. Okay? Now the other thing you'll see on this slide is some fancy, well, something like this. Okay, remember we talked about parentheses, brackets, and braces earlier? So it's written like this. 9 over 2 and infinity. Okay? We use the bracket because it includes the number 9 over 2. Okay? That is included. That is a solution because of the equal to sign. It's included. We use the parentheses, well, because you can never get to the end of infinity, so you can't say the last number is included because there is no last number. So that's how root functions work.